Okay, let's go ahead in part 3 and we'll finish this equation here. So we have 1 over 32 can be rewritten as 2 to the negative 5th power. Go ahead and use that power property. So it's 2 to the 6x power is equal to 2 to the negative 5 power. And now you can set your exponents equal to each other. Divide both sides by 6. And you get x is equal to negative 5 over 6. That means 64 to the negative 5 over 6 power is equal to 1 over 32. Okay, and number 3, we're going to rewrite it first as an equation. So I have log base 9 of 27 is equal to x. And now write it as an exponential equation. We have 9 to the x power is equal to 27. And remember, I can rewrite my bases here. 9 can be rewritten as 3 squared, and 27 can be rewritten as 3 cubed. Using that power property, 3 to the 2x power equals 3 cubed. And now I can set my exponents equal to each other. Solving for x, I get x is equal to 3 over 2. Okay. And our last example here, we have log base 10 of 100. Log base 10 of 100 is equal to x. Rewrite it as an exponential equation, so it's 10 to the x power equals 100. And I can rewrite so that I have a base of 10. 100 is 10 squared, and set the exponents equal to each other. And now that we're talking about log with a base of 10, you need to put down another definition, and that would be a common log. A common logarithm is a logarithm that uses base 10. And you can write the common logarithm, so we have log base 10 of y, as just log of y. And this is an assumed base of 10, and your calculators assume that base of 10. Scientists often use common logarithms to measure acidity. Perhaps you've already done this in your chemistry class, so this should be a little bit familiar to you. It increases, which increases as the concentration of hydrogen ions in a substance increases. The pH of a substance equals negative log of the hydrogen ion concentration, where that hydrogen ion concentration is labeled as this. Okay? An example of this would be, we have the pH of lemon juice is 2.3, while the pH of milk is 6.6. We're being asked to find the concentration of hydrogen ions in each substance and then determine which substance is more acidic. So in order to do that, we're first going to use that for starting with the lemon juice. And we know its pH is equal to negative log of the hydrogen ion concentration. The pH as given for lemon juice is 2.3. And my unknown is going to be this hydrogen ion concentration. So I can actually rewrite that, putting an x in there. And I can then use my algebra properties to know that I can divide both sides by negative 1. So I have negative 2.3 equals log, and let's just use x now for our unknown. Remember, there's an assumed base of 10 right here, so I know that the log base 10 of x is equal to negative 2.3. Rewriting that, my base of 10 to the negative 2.3 power is equal to x, and I can approximate that at 5.0 times 10 to the negative 3 power. Now we also need to find the pH, or find the hydrogen ion concentration of milk. That was given to us as 6.6. Remember that right here, this negative log, I can divide both sides by a negative 1, so I have negative 6.6 is equal to log, and we're going to use x to represent the hydrogen ion concentration. So my base of 10 to the negative 6.6 power is equal to x, and x is approximately 2.5 times 10 to the negative 7 power. Okay, and one final example. Find the hydrogen, oh, I forgot to answer, which substance is more acidic? Well, the substance that's most acidic right here would be the lemon juice. All right, and now we need to find the concentration of hydrogen ions in seawater with a pH of 8.5. And remember, our representation is negative log of the hydrogen ion concentration. I can rewrite that, and I'll help you out with the step here. It's log base 10 of some unknown is equal to the pH of 8.5. Excuse me, there's a negative there. And we need to divide both sides by a negative, and we can rewrite it as 10 to the negative 8.5 power is equal to x. So x is approximately 3.2 times 10 to the negative 9 power.